Polar coordinates. So fixed point O. Fixed point O right here. That's the fixed point O. It's called the pole or origin. Pole or origin. So O, we're going to construct an initial ray called the polar axis. So we switch what you used to know about graphing into unit circle style, which is oh so fun. Okay, so like this part, R is the directed distance from O to P. It's just a radius. Like, who cares about directed distance? It's fine. It's just a radius. Now, what is the radius on the unit circle? Positive or negative? Positive always, right? So we'll deal with some negative radii. Like this is a negative radius, and then we have to do some stuff. Okay? So that's the confusing part of this. So that's what I'm going to talk about right down here. When R is negative, and you'll forget about this rule because we'll use coterminal angles as well. What do I add or subtract if I want a coterminal angle in terms of radians? 2 pi. I either add or subtract 2 pi. When R is negative, all we do is we switch the R to positive, and then we do whatever theta is plus the equivalent of pi. And many times you'll have to get a common denominator when we do that. Okay, so we're going to learn how to graph points in the polar coordinate plane over here. So you can look at that. Oh, people need unit circles. You want a unit circle for sure. Unit circles. Who else needs unit circle? Chatterheads. There you go. Yep. You guys want? There you go. There you go. There you go. You good? Okay. You can look on that one if someone's guessed right. They want another. Okay. Anyone else? Okay. Anyone else need a unit circle? We good? Okay. So you'll notice on this polar coordinate plane over here, we have concentric circles. Circles get bigger and bigger and bigger as you go around, right? So we're looking at this 2. That's the radius measure, right? It goes r theta, like this. So the r is the radius, theta is the angle measure in radians, usually, almost always. So we go to the second. You can see right here, barely, it's kind of blurry, but there's a 2 right there. And then we go to 7 pi over 6. So I follow this around, and I make my dot right here at 7 pi over 6. Okay? So I'm going to make my dot right there. And we're going to label that point, right? Because it's making us graph 6 different points. So we're going to label that point A. So the graphing's not bad, right? It only gets weird when you get a negative radius, because then we have to add the equivalent of pi. So we'll graph the second one next. So we have 0.5 and 3 pi over 4. So where's 3? Which quadrant's 3 pi over 4? 2. Where is it in 2? It's exactly halfway, right? So the exactly halfway, 3 pi over 4 is right here. So keep that in mind. And then 1 is right here. So I want to be in the innermost circle, halfway on quadrant 2. Which is right there, and label that one B, so you can see. Right, concentric circles are like this, and then bigger and bigger and bigger. Okay, so that's B. Now, all we have is a negative radian measure. So if I want negative pi over 3, what value is that actually? 5 pi over 3, good. Right, so the way the trick for that, I find positive 5 pi over 3 rather, and just go straight down, and that's negative. Okay, so I want to graph it at 5 pi over 3. So if you need to write that down, write that down. This is really 5 pi over 3. And then we're going to go to the outermost circle and make a dot at 5 pi over 3, and that is point C. So this is like a really easy test question for me to give you, this kind of problem, so expect to see it on your test. Okay? Now we're dealing with a negative radius. So our little formula up here says if I have a negative radius, what do? I make the r positive, and I add the equivalent of pi. So instead of -1, it's +1. And then if I add pi, what do I add common denominator-wise? 4 pi over 4, right? Just the denominator of the denominator. So the denominator is 4, so I do 4 pi over 4. What do I get? 5 pi over 4. So I'm going to graph 5 pi over 4. So where's 5 pi over 4? Because it doesn't list all the radians, right? Which middle of the third, right? So we're going 1. So that's a second circle right there. So we get, that is point D. So try 5 on your own, right? Just so you get used to this thing. I'll freeze my screen and then I'll put it up here. So you got to make radius positive, add pi, the equivalent of pi. Oh, this is tricky too, because 7 pi over 3 is not on the unit circle. So now, actually, let's not do that. So we get 7 pi over 3. What would be on the unit circle? How many pi's over 3? 6 pi over 3 is 1 revolution around, right? So I'm over 1 revolution around. So what do I have to do? Add or subtract the equivalent of 2 pi? Subtract, because I want to get that coterminal angle. So I'm going to do 7 pi over 3 minus what? Double the denominator, 6 pi over 3. This is a moment where you got to ask questions if you didn't understand what just happened. Right? So first thing we did is we made the radius positive and we added pi. That's what we did right here. Then I got 7 pi over 3, but 7 pi over 3 is more than 1 revolution on the unit circle. So I have to subtract a coterminal angle, and 6 divided by 3 is 2 pi, right? So I subtracted 2 pi. So 7 pi over 3 minus 6 pi over 3 is pi over 3. So that's as much work as you could possibly have to do on this kind of problem. That's kind of a pain. So E is 2.5. So that's the second most outermost circle. So right there. And then that is point E. Try the next one isn't as bad. So try the next one on your own. Once you're done, you can check. What did we have to add? We had to add 6 pi over 6 right here, right? So 6 pi over 6, negative pi over 6 plus 6 pi over 6 is 5 pi over 6 right here, okay? So 5 pi over 6 is right here. And it gets more challenging from there, just so you know. It's a lot going on this first section of the polar coordinates. Okay, so this, so I'm just going to read this. So while each pair of polar coordinates plots a unique point, each point does not have unique coordinates. In general, a point with polar coordinates r theta can also be represented by, so this kind of stuff never really helped me. I just kind of figure out how it works, which we'll talk about. But if this helps you, it's great. So theta plus 2n pi. So remember in the last test where we were finding values on the unit circle and we needed to, the range of domain values was from negative infinity to positive infinity, and we had to add 2n pi, or if it was tangent, we'd add n pi. So that's kind of the thought process here. So that's one of them. If it's negative, so if r is negative, we have to take theta, and we're going to add this, like, if this helps you, more power to you. It doesn't work for me, but we'll talk about how it works, and it'll make more sense once I explain it. Like, those formulas are terrible. I'd be like, I have no idea what to do. Okay, so here's the gist of what's going on here. So first of all, our range is from negative 2 pi to positive 2 pi. So any radian measure we get has to fall within that range, negative 2 pi to positive 2 pi. So I want to get I want 2 positive r's and 2 negative r's. So if I get a second positive r, I want to end up at the exact same ordered pair, right? Like up here, exact same ordered pair. So what do I have to add to this 5 pi over 3 to make it in the same place? Or subtract, as the case may be. So do I add or subtract 2 pi? Because 5 pi over 3 is really close to 2 pi, right? So then I'm going to have to subtract to go around this way, right? To end up in the same place. So if I subtract, what do I subtract though? 6 pi over 3. Double the denominator. That's the easiest way to remember to deal with that 2 pi, right? So 5 pi over 3 minus 6 pi over 3 is negative pi over 3. And then I want to just look at my little range right here, right? So is that in between negative 2 pi and positive 2 pi? Sure is, so I'm good. Okay? Whereas if I were to add 6 pi over 3 right here, I get 11 pi over 3 and it's too big, right? Okay? So we have our 2 positives. Now I need 2 negatives. So if I change my radius to negative, what do I have to do? Right? So right here, we're doing this part. So I'm adding or subtracting pi. So I'm going to add pi. And I'm going to add pi to, it doesn't really matter if you think about it. 1 second, then I'll take your question. Right? So if I add pi to the top one, is that okay? So if I add a pi, I'm going to erase this 6 pi over 3. So if I add a pi to this one, am I going to be on the unit circle? Right? Because it'll be bigger than 6 pi over 3, right? But if I add pi to this one, I'm going to be okay. So I'm going to add pi to negative pi over 3. So negative pi over 3 plus, that's beautiful, 3, plus 3 pi over 3, right? Equivalent to pi. And what do I get? 2 pi over 3. Okay, now I have to figure out a coterminal angle with that. So do I add or subtract 2 pi? Right, so both positives have to be coterminal. Both negatives have to be coterminal. If that's going to help you remember how to do this, that's not a bad thing to write down, right? So both positives have to be coterminal, meaning you're going to add or subtract 2 pi from one of them to get the other. And both negatives have to be coterminal, meaning you'll add or subtract the equivalent of 2 pi. Okay? So should I add or subtract 2 pi to 2 pi over 3? Subtract. So I'm going to subtract 6 pi over 3. And I get negative 4 pi over 3. Is negative 4 pi over 3 within this range right here? Sure is. Right, so my third point then is negative 2, negative 4 pi over 3. We're going to do one more together, and then I want you to try and struggle through one of these. Okay. It's super confusing. Okay, we're going to practice. So I look at number 8. Go ahead.
So is there ever going to be an instance where, so you're just always taking the y and adding to pi to get the next?
Unless we switch from negative to positive, then I either only add or subtract pi.
You know if you have to switch.
Because once, like right here, I have the negative, right? So this one I have the negative. I'm going to get the second negative by dealing with coterminal. So add or subtract 2 pi. And then when I switch from negative 5 to positive 5, that's when I'm going to add pi.
Okay.
So when the radius switches from positive to negative, add pi.
Okay.
That's a good thing to write down as well to help you kind of keep it straight. So if I'm at negative 7 pi over 4, I need a coterminal angle. What do I have to add to that? And then I never answered your question, Jordan, but are you good? You can ask her about the previous one. Okay, let's just keep going, right? And we'll keep practicing. And you'll do the homework as well, and you need all of that practice to figure it out. That's like, how many, raise your hand, like fist to 5 right now. Fists, I'm totally confused. 5, I totally get it. And look around just so you get where people are at. Okay, so you're not alone, right? And this is why we keep practicing. You'll get better. You can do it, right? So I want my second negative value, right? So I need a negative 5. And when I keep it negative, that's when I need coterminal. So if I need a coterminal angle to negative 7 pi over 4, what do I need to do? Add or subtract 2 pi? Add. So I double the denominator and I add 8 pi over 4. So the thing is, I learned when I took calculus, which I've said before in here, is like embrace the confusion, but know you're going to understand. And there be parts of this you just won't get, and that's fine. You can miss one question on a test and still get an A. You can. It's okay. And you can get partial credit, right? What do I get? 8 pi or negative 7 pi over 4. Do I have both negatives? Yes. So now what do I have to do? Right? So I have both negative values. I got coterminal angles. That's what I mean. Okay. Now I need both positives.
No, it's not.
So I have positive, or let me write it down here. So I have positive 5. I'm going to erase the 8 pi over 4 so it's not confusing. Okay. Now I need to add the equivalent of pi. It doesn't matter which one I add it to. So you just pick one. Doesn't matter at all. Yeah.
So right now, we switch from negative to positive, so then are we just...
When you switch from negative to positive, you have to add pi.
So we add 4 pi over 4 pi.
Yes. So we're going to add 4 pi over 4. What do I get?
5 pi over 4.
Negative 7 plus 4. Oh, you did it to the other one. 5 pi over 4 is going to be, so we get what? Negative 3 pi over 4.
Is 5 pi over 4 also right though?
You'll see, watch. So if I have negative 3 pi over 4 and I need a coterminal angle, do I add or subtract? Add. What do I add? 8 pi over 4. Good. And what do I get? So that's why it doesn't matter which one you add first. Right. Okay. That's the weird part, yeah? So 5, because we're getting coterminal angle, that's why it stays positive, okay? So we get 5 pi over 4. That was good moment for some of you, right? Some people feel better about it now. Do you want to try? Yeah, you should try this last one on your own. Doesn't matter. Could be anything, right? Doesn't matter at all. Right, so get the second negative one first. And what are you doing, coterminal or adding pi? Coterminal. Good, you're getting it. It's good. It's hard though, right? Why is my phone all hot? It's burning up. Yes, I think, but I don't know what you're doing, so it's hard to know. Tell me when you want me to put it up there, and I will. Sometimes kids like to work on it a little bit. That's the tricky part right there. You're like, what the hell's going on? Okay, you want to see? You can just don't look up if you don't want to see. Now, if you didn't get one of them, you can ask me and I'll explain what happened. Yeah, which one?
She said the whole thing.
The whole thing.
I got every single one wrong.
Oh. So let's start from the, I'm going to erase it and just start and we'll kind of do it together, okay? Because it's better than seeing all this because it gets confusing, as you can tell. What part? All of it. Okay. So I want my second negative. That's my first step, right? Because I already have it negative. So I want to do another negative 1.5 as my radius. And I need a coterminal angle to pi over 6. So coterminal angle is the double denominator. So I'd write coterminal on the side. This kind of stuff helps. Equals double denominator. Okay, so if I double the denominator, I'm going to add, or now here's the thing, do I add or subtract 12 pi over 6? I have to subtract, right? Because otherwise I'm going to be greater than 12 pi over 6. So that's why I have to subtract 12 pi over 6 here. And if I do 1 minus 12, I get negative 11. So that's why this one's negative 11 pi over 6. Okay? So I'm going to erase this minus 12 pi over 6 because it confuses if I don't. Now I need to switch it to positive. When I switch to positive, I need to add pi. Okay? So if I add pi to this right here, so I'm going to switch to positive, write 1.5 in the parenthesis. I'm going to add pi. So then I add 6 pi over 6. So 1 plus 6 is 7 pi over 6. Okay? Now I want my second positive, so I need coterminal. What do? Double the denominator. So I have 1.5. And if I double the denominator, if I were to add right here, 12 pi over 6, I'd be off the unit circle, right? So I want to subtract 12 pi over 6. So 7 pi over 6 minus 12 pi over 6. So 7 minus 12 is negative 5 pi over 6. Okay? So the issue with this test is we'll do this. You'll work on the homework and you'll understand it at whatever level you understand it. Your test is until the block day before Thanksgiving break. So if you think about 2.5 weeks from now, are you going to remember this? Hell no. I have to do it. I was watching Gina's video this morning to remind me how to do this, right? And then I take how she explains it. If you watch that and see how she explains it, you'd be like, what the? But I've explained it the best I ever have this year because I finally get it. It's confusing though. So gigantic square root. We got a nasty little formula coming up.
Oh, awesome.
It's basically law of cosines, okay, just with radius and theta. And we're solving for that side length. So we're trying to figure out the distance between 2 points on the polar coordinate plane. Will you get this formula? Yes, you will. Okay, so it's going to be okay. But it's still a pain in the neck, right?
I did A, B, instead of like R squared once.
As long as you can understand what to plug in, that's fine. Okay? So gigantic square root. We're going to do the 2 radius So 2 squared plus 3 squared minus 2 times 2 times 3. And then we have cosine. Now I have a common denominator, so I do second radian measure minus first radian measure. I'm going to leave minus pi over 3. We need a common denominator to subtract those two fractions. What is my common denominator? 12. What do I have to multiply the first fraction by? 3 over 3. Second fraction by? 4 over 4. So I get 21 pi over 12 minus 4 pi over 12. So 21 minus 4 is 17 pi over 12. So that's what we're going to plug in here, 17 pi. So if you think about your calculator, what does your calculator have to be in? Radians. So if you got to switch it now, right? Now you got to remember that. Now if you didn't want to switch it, if you want to keep it in degrees, you could switch this to degrees, right? But it's one more step, and you might make a mistake doing that one more. But are you going to make a mistake switching your calculator? Maybe. So you make the call. Like, I don't care which way you do it. And then you can see I have it up here. Remember, you can do alpha y equals and put that fraction in if you want. But put the fraction in parentheses. Yeah.
Are you going to give us this formula on the
Yeah.
test? Okay.
I've got the formula sheet. It's got law sines, law cosines, and then that formula's on there as well, yeah. I was like, I crossed it off, but it's going to be on there. Okay? So make sure you hit mode to switch it to radians, right? And then plug that in. Make sure you get 4.01. That's a distance in between those 2 points in the polar coordinate plane.
So you did 1 squared.
No, that's the second one up. That's the next one we're going to do. So it's a middle one up there. Just let me know if you need help on your calculator. And we still have like a decent amount left. You can come up, yeah, if you got a question.
Wait, why did
I'm putting in radians, and I think I understood it, right?
2 times 2 times 3. It's in radians. It should work. That's not very good. All right, I'm gonna go like this. I'm gonna reset it. So you can go second mem right there. I would do it like before any tests, right? Just in case there's something weird in there. Like, kids can be evil. Like, when my friends had these, I would switch their calculator to Dutch and not say anything, and then watch them sweat during a test, and they're like, "You're such a... I can't believe you did that," right? So I would switch it to degrees, like mess with people. You can also store values. So every time they plug in a 2, it's actually a 3. Right? So you can mess with people at like epic levels. I know, right? But my friends, we were smart, so we figured it out. We'd be like, that doesn't make sense. But it is totally evil, I agree. All right, so we're going to plug. So you go second mem, and for whatever reason, resets number 7. And RAM works better to reset. You would think default works better, but it doesn't. And then we're going to go second. Here, you can look right there, the middle one. So 2 squared plus 3 squared. I wonder if he did times. I swear to God it was exactly right, though. Minus 2 times 2 times 3. Cosine. And then alpha y equals...
Yeah,
Or,
this.
oh, yours is different. Yeah. So 17 pi over 12. Close that parenthesis. Good. There it is. Okay. I don't know why it didn't work the first time. Okay, we good? The fun keeps coming. Did you get 4.01? It's the middle one you're looking at, right? Anyone need... We good? Yeah? Okay. We keep going. Do you need to do one more of those, or are you good? You're just plugging into the formula, right? So just get common denominator. You can do it in degrees, right? Like number 12. So if we have degrees, you just got to switch your calculator back to degrees, and the same formula applies, right? And this one, we'd be doing second one minus minus first one, so it'd actually be plus. Okay? And then actually that's not going to be on the unit circle, so you'd need a coterminal angle. So you'd need to subtract 360 on this one. Okay? Yeah.
When you're plugging in r and r squared, do you plug it in as a negative? Like if it's negative 1, would you plug it in?
So this one, it'll work either way, but you can switch this to positive 1, right?
Oh, and then switch.
You can add 6 pi over 6, which is not on the unit circle, and subtract 12 pi over 6. I think it'll work if you don't. But you try it right now. Yeah, I'm not positive. Because I did it where I switched it.
I'll try.
Yeah, let's try it without. And you should get, this is when I switched it to positive 1. You got it? And you didn't, you did or did not? Okay.
Parentheses, -1, parentheses.
Yeah. So it'll work if you don't switch. It'll work if you switch it. Either way. Yes. You got to remember to put that -1 in parentheses, otherwise you're in trouble.
What unit do I use?
For,
0.01 what? Just 4.01.
there are no units. It's just a measure of distance. Units is what you would say. Yeah. You don't have to write anything. No, it's fine. Yeah.
For the second one,
Yep.
how'd you get pi over?
So I did 2 pi over 3 minus 11 pi over 6. And this I have to multiply by 2 over 2.
But wouldn't it be negative 7 pi over 6? It would, you just did something.
Oh, I did it backwards. Come on. I did 2 pi over 3. No, I didn't. 2 pi over 3 minus 11 pi over 6. So it'd be negative 7 pi over 6, right? So that's fine, because the one I did, I switched the radius to positive, and I got the angle, right, by adding pi over 6 pi over 6, blah, blah, blah. So if you don't switch it, you would get negative 7 pi over 6. Yes, it's good. What up? It's a tough one to miss, but I'm sure it'll be quick. Are we good on that one then? We good? So you don't have to switch it to positive radius. So the formula still works. Okay? Now we go to this. More. So it says radius equals 2. All you have to do with this problem is you find 2 and you just make a circle. Oh, that's a wiggly circle. Right? Because r equals 2. That's the answer. That's all you got to do. So what do you do with negative? Make it positive. And there's nothing else to switch, so you don't have to switch anything. So 4.5. We're going to make it smaller. Because I can adjust my little circle. Because that's what you have to do. There's no radian measure to have to mess with. If there were a radian measure, we'd have to mess with it, right? So you just switch it. Because there's no negatives on the unit circle. So what else are you going to do? You'd be in a parallel universe if you made it negative. They'd get some weird stuff happening. Okay. So now we got pi over 3. So, get to that. So all we got to do is from here, if I add 3 pi over 3, I just get that. So this is how I would, well, let's just do that first. So I just draw I draw pi over 3, right? Because that's what my measure is right here. And just keep going. Go all the way across. That's the easiest way to figure it out. Just go all the way across. So if I have negative 7 pi over 6, what value do I want? 5 pi over 6. So I'm going to draw 5 pi over 6 and keep going. Okay? So those are the easy ones. You just got to remember to draw all the way across the unit circle. These are the hard ones. Can't have negative. It's not on the unit circle. Well, it's not. It's adding pi, right?
Oh, it's just adding pi?
Yeah.
Is it all the problems?
Oh, it erased. That's unfortunate. Oh no, I think I have it on. No, it's not all the problems over today and Friday. Yes, but it's a mixture today. I think. Did I do period 3? No, I did period 1. That's unfortunate. I'll tell you what it is. You don't know yet, though. Okay, this is the hard stuff. You want to look at your unit circle. So look right up here. I have 2 sine theta. We're going to graph 2 sine theta. I want to show you what the graphs look like. No, I don't want to do that. Let's do this one. I just want to show you all the different kinds of graphs because it's crazy. So look at all those different graphs. Okay? So we're going to start with cosine and sine graphing. So what is cosine, x or y? X, right? So if I graph positive, right? Positive cosine, it should be on positive x on the unit circle. And you get this weird looking kind of circle-ish thing. It's not totally circle, but kind of. If I do negative cosine, right? A is less than 0. It's going to be on the negative x, my graph. Then if I look at sine, all you need to worry about is these right now. Okay? So if I do sine, that's y, right? So I have positive y is going to be above the x-axis, negative y below x-axis. So that'll help you once you start to do this so you know where your dots should be. So first thing we're going to do is positive sine, but we're multiplying it by 2 as well. That's the tricky part. Okay, so you look at your unit circle and you try to find where sine is 0. What's the measure when sine is 0? I put them over here. The angle measure is 0. What is the sine value? The side length. Sine is y? 0. What's 2 times 0? 0. Remember, if we get negative r values, what do we have to do? Switch it to positive, and do I add pi or 2 pi? Yes. Okay, because that happens on these. And these are the easy ones, right? Because we'll do cosecant, which is 1 over sine. So you're flipping them. That's what we do tomorrow, but we just do sine and cosine today, so you can get those down. You'll see. It's going to be okay. So pi over 6, what is the y value? Pi over 6, the y value is 1/2. What do I have to multiply it by? 2. So I do 1/2 times 2, and what do I get? 1. We're going to worry about graphing them later. So pi over 3, what do I get? 3 pi over 2. So just so you know, I would write this off to the side. 3 pi over 2 is like 0.866. So you could just think of it like 0.9, because that's relatively easy to graph, 0.9. Okay, so the y value here is root 3 over 2. What do I have to multiply it by? 2. So what do I get? Root 3. Root 3 is about 1.7, just so you know. So when we'll have to graph 1.7 on the little concentric circles. Okay? You could put it in your calculator, right? Because I let you use calculators for everything. Okay? So pi over 2, what's a y value? 1. What do I have to multiply it by? 2. So I get 2. So 2 pi over 3. What's a y value? Root 3 over 2. What do I multiply it by? 2. And I get root 3, which is about 1.7. 5 pi over 6, what's a y value? 1/2 times 2 is 1. So if I have a regular sign, I'm not doing any of that times 2 stuff. Okay? So that when I multiply by 2, it makes my little circle on the right side of the polar coordinate plane bigger, right? Because I'm multiplying it by 2. If it's a regular sign, it's going to be closer to the origin. If I did 1/2 sign, it would be even closer to the origin. Okay, so you think about like 2 is a vertical stretch, so it makes it bigger. The whole thing gets bigger. So let's graph it. We start at 0, 0. Then I have pi over 6, 1. So we're talking about sign. Which side of the unit circle should I be on? Left, right, up, or down? Positive sign.
Yeah.
Up, right? Positive sign is up. So if you get a point that's down in the bottom of the unit circle, you screwed up, right? So it's a good built-in double check so you know. So we get pi over 3, 1.7. So about right there. And then we get pi over 2, 2. Right? And I'm on positive y, so I'm good. We get 2 pi over 3, 1.7. Oh, this point was wrong right here. I need to move that out. 1.7 would be like right here. And 2 pi over 3, 1.7. And then what do I have? I get 5 pi over 6, 1. So it's like the circle's like pinched a little bit at the bottom. That was wiggly, but whatever. Close enough. Okay? It's not helping. It's worse, I think, but it's okay. Okay. So first thing I want to do on the cosine is write my little chart down. You notice on I gave you that extra sheet of paper today. So if you get homework problems and you want to graph them on that piece of paper, totally fine, right? And I'll have more of them so you can practice once the test rolls around, because you'll definitely want to practice this, okay? So draw that chart and fill all that stuff out on the left side over here, because you don't have that, right? So draw that chart over here. And we're doing just straight up cosine. So which side of the unit circle is it going to be on? Cosine? Right, left, up, or down? Positive x. Right, for you guys this way. My left is your right as you look at me. Exactly. I don't know. So get that chart down and then we'll start going. You get negatives here with cosine, so we'll need to do our little add pi thing. If you're done with the chart, you can start filling it out. Like, that's fine. And I'll fill it out as we go. I just wanted to wait till people have the chart down. Now that I told you to write the chart, you could have done it on the paper, just saying. Graph cosine on the paper, right, that I gave you at the beginning of class. But, oh well. Tomorrow you can graph them all on the paper so you don't have to continue to write the chart because it's irritating to write the chart. Okay, are we good? Ready to go? Cosine, when cosine is 0, what do we get? X value at 0 is 1. I don't multiply it by anything, right? Because there's nothing in front of cosine. Pi over 6, what's the cosine value? Root 3 over 2. Okay, that's about 0.9. So I'm going to write that decimal equivalent always because it just makes it easier to graph. Pi over 3, what's the x value? 1/2. Pi over 2, what's the x value? 0. 2 pi over 3, what's the x value? Negative 1/2. So I'm going to make that positive 1/2. And then what do I have to do to 2 pi over 3? Because I switch the radius from negative to positive, I got to add pi. So I add 3 pi over 3 over here. And what do I get? 5 pi over 3. Okay, when I do 5 pi over 6, I get negative root 3 over 2. I make it positive root 3 over 2. And I add the equivalent of pi, which is 6 pi over 6. That gives me 11 pi over 6. Then remember, root 3 over 2 is 0.9. 1/2 is 0.5. That makes it easier to graph it. We just have the decimals. So we have a point at 0, 1. We have a point at pi over 6, 0.9. So this one's going to be tighter to the origin, right? Because we didn't multiply it by 2. So it should seem closer, right? So pi over 3 is 0.5. That's an innermost circle. And then pi over 2 is 0. So we're going kind of counterclockwise around our little circle-y looking thing. So we have 5 pi over 3, 0.5. And then we have 11 pi over 6, 0.9. That was a better one. Okay. That is it. So tomorrow.